Now let's talk about the alternate definition of the derivative. So this will be pretty quick, but it's still something worth looking at. So we know that just the regular definition of the derivative says that f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all divided by h. So how do we go from here to this alternate definition here? Well, we're going to make a substitution. We're going to substitute t equals x plus h. So if t is x plus h, then subtract x from both sides, and we get h equals t minus x. Also, here, in this original limit, we're taking a limit as h goes to 0. Well, if h goes to 0 and h is t minus x, then that means t minus x goes to 0. And this little expression right here, t minus x goes to 0, we can add x to both sides of that, and t minus x goes to 0 means t goes to x. Therefore, if h goes to 0, then t goes to x, under this substitution that we're making here. So, now we can put everything together, and we have f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all divided by h. So now that equals the limit as t goes to x, because remember, t goes to x as h goes to 0. And then, because we're making the substitution t equals x plus h, then f of x plus h gets replaced with f of t. And we still have our minus f of x up there. And finally, h is t minus x, so we have t minus x down here. And that's how we can establish the alternate definition of the derivative here. So the benefit of this is if we have to calculate a derivative using the limit definition, then sometimes the alternate definition is going to be a little bit easier to use. And if you want to prove or explain certain things, like the chain rule, for example, it's going to be a little bit easier with the alternate definition than with this more standard typical definition over here.